All right, here's a video. Because Nat asked me to make solutions for quiz 7 and 8, I thought I'd make a video instead and maybe talk more than just spit out a piece of paper with a bunch of solutions on it. So here we are. Here's the problem. We have we're integrating this guy here along the curve C, which is made up of C1 and C2. So first we parameterize C1. And I'll call this R1 of t, and it's a circular radius 2, so it's going to be 2 cosine t I plus 2 sine t j, and t runs from minus pi over 2 to pi over 2. So you have, that's your first interval. And then for the second parametrization, R2 of t, it's going to be what? Well, first we need the v, right? So v is the vector that's parallel to this line, and that is what? It's going this way? Yeah. So it's minus 3 minus 0 I plus minus 4 minus 2j. So this is minus 3i minus 6j. Okay, so in this line equation, it's going to be what? X equals 0 minus 3t, and y equals two minus 6t. So plugging this into R of t, we have minus 3t I plus 2 minus 6t j, and t runs from 0 to 1. Okay. All right, so now we have our pieces. So the integral of c, what is it? Y squared plus x squared ds is the first curve here, plus the second curve. And let's see, on C1, t goes from minus pi over 2 to pi over 2. Y squared, so what's y? Y is 2 sine t. So we have 2 sine t squared plus x squared, which is 2 cosine squared t times what? Times this guy. This guy, which is, what is it? It is 2. Or is it root 2? Let's see, hold on. So derivative of x prime squared plus y prime squared. So x prime squared plus y prime squared equals x prime is minus 2 sine, so 4 sine squared, plus 4 cosine squared. Sure enough, that's 2. All right, so we put it all together. We have minus pi over 2, 4 sine squared t plus 4 cosine squared t times 2 dt. Get some color in here. This becomes 4. So we get 8 times the integral from pi over 2 to minus pi over 2 dt. And so that is 8 times pi over 2 minus a minus pi over 2, and that is 8 pi for the first integral. Okay. And for the second integral, C2, we have, see here, in blue, y squared plus x squared ds, which is t runs from 0 to 1. What's y? Y is 2 minus 6t. X is minus 3t. And what is r prime? R2 prime. R2 prime is minus 3i minus 6j, and the norm of that is 3 squared plus 6 squared, which is 36 plus 9, which is root 45. All right. So out here we have a root 45 dt. Root 45 comes out front, we go from 0 to 1. 2 minus 6t squared. What's that? 4 minus 24t plus 36t squared plus 9t squared dt. So 4 minus 24t plus 45t squared dt. So this is 4t minus 12t squared plus 15t cubed, evaluated from 0 to 1. And that's root 45 times 4 minus 12 plus 15, which is 7. So the answer is 7 root 45 plus 8 pi. Okay. Problem 2, so quiz 7, number 2. We're given the field y squared I plus 2xy j. Check this out. I'm going to do this a little differently than we did it then. So this is a field, and we're integrating along the line segment from 1, 1 to 2, 1. My is 2y. Nx is 2y. Hence, f is conservative. And so we need to find the potential function f such that del f equals this guy, right? Okay, and then we can use the fundamental theorem of line integrals. All right, so we know that fx equals m. So that f is equal to the integral of m dx, which is the integral of 2y dx. And this is 2xy plus a constant in terms of y, right? So that's our first round of f. And we also know that fy equals n. So if you take the derivative of this guy with respect to y, so if you take the partial with respect to y of 2xy plus h of y, this has to equal n. And that partial is what? It's 2x plus h prime of y. And that equals I made a major mistake. I used this for m. Hold on, let me back up here. Let me back up here. Back up. Back up. M is y squared. So this is going to be xy squared plus a function of y. That's better. You know, 2 f sub y equals n. And what's f sub y? F sub y is 2xy plus h prime of y, and that equals n, which is 2xy. This says h prime of y equals a constant. Sorry, h prime of y equals 0. So h of y equals a constant. So here's my function. I'll ignore the constant. Right? So if this is my function, f sub x is y squared, that equals m. F sub y is 2xy, and that equals n. Okay? And by the fundamental theorem of line integrals, the integral along the curve from 1, 1 to 2, 1 of f dot dr is f of 2, 1 minus f of 1, 1. And this is 2 minus 1, and that equals 1. Okay, quiz 8. Problem 1. We're computing f dot dr, which happens to be the double integral over r of nx minus my dA, which is nx is 2, my is 3 dA. So this is minus the region there, and the area of an ellipse is area equals pi AB, which is pi times 1 times root 2. So the final answer is minus pi root 2. And quiz 8, number 2. What do we got here? Oh, this is a good one. Here's our. So we have xy dy minus y squared dx. And remember, Green's theorem says this. It says m dx plus n dy equals the double integral over the region R of n sub x minus my dA. Right? And so in this game we have, I'm going to rewrite this, we have minus y squared dx plus xy dy, so that m equals minus y squared and n equals xy in this formula. So let's see here, what's nx? It is y. My is minus 2y dA. And so this is going to be, what do we got here? X equals 1. Oh, x goes from 0 to 1. Y goes from 0 to 1. 3y dy dx. X goes from 0 to 1. 3y squared over 2. Evaluated from 0 to 1 dx. So this becomes 3/2 times the interval from 0 to 1 dx, and that is 3/2. Thanks for watching.